Well, it is 10 o'clock, which means that it's time for another Vinimark webinar. And in the preparation for this particular episode, which is titled Artificial Intelligence in Wine, the Ethics, Opportunities and Applications, I found myself mulling over the following quote, which says, AI is not going to replace humans, but humans with AI will replace those without it. And this quote single-handedly inspired me to at least try and take the South African wine industry, beyond Thunderdome, through the blue sky opportunities and into the glorious infinite galaxy of profitability and efficiency. It was really a beautiful vision. But then I started chatting to actual AI experts, and I realized just how much hard work you have to do before you can get an AI to do all your hard work. But luckily, many of the voices that informed that caution are joining us today. And we've put these guys together because they are some of the very few people in the world today that actually get paid to think beyond the immediate applications and to ask questions about the implications of our actions. So these international thought leaders have looked at AI in connection to things like viticulture and winemaking and also wine marketing. And so today, they're not only going to help us discover new ways to apply AI, but they're also going to give us frameworks through which we can evaluate those AIs. Now, as always, the purpose of these Vinimark webinars is to give practical applications that can make an immediate benefit to your wine businesses. But today, for every opportunity or applications we explore, we are also going to unpack the potential pitfalls and the possible ethical considerations that you have to make before you can dive in. So on our panel today, we have John Bradshaw, who's the former head of marketing for Pick and Pay, and he's also the founder of Baobab AI Consultancy. Next, we have Albert Strewers, who's a senior lecturer at the Department of Viticulture and Enology at Stellenbosch University. And finally, we have Kira Lamprecht, who is an expert in mathematical modeling and process control, and she's been exploring the connection with machine learning in the wine cellar and in the winemaking process. Now, before we get to those applications, I wanted to ask Albert Strewers to give us some foundational knowledge on the topic. And just in case any of you guys were wondering, if you've ever consulted somebody at Vinpro, like Etienne Tabranche, for example, on the subject of viticulture and thought, shoo, but that Etienne guy is very smart. Well, Albert is the guy that Etienne consults on things like AI. And when Etienne gets off the phone with Albert, Etienne thinks to himself, shoo, but that Albert is smart. So with that context, I want to ask this, Albert. The term AI is ubiquitous, and so much so that I think many of us have forgotten about the base principles that underpin the term, or even worse, we haven't begun to even think about what makes an intelligence artificial. So my question to you at the beginning is, can you kind of tease out the differences between artificial intelligence and, say, human intelligence, and why is that distinction important?
Yeah, let's first maybe talk about the analogies between human intelligence and artificial intelligence, and that's the concept of neural networks and the way our brains work. It joins neurons and it joins electrical impulses for us to make quite complex calculations and decisions in a millisecond or even shorter time frame. So AI, where it's the same, is that it also uses the concepts of neural networks to do predictive modeling. And in essence, AI is a language predictive modeling model that uses language models to essentially predict the next word from complex modeling using machine learning. So some of you might be familiar with machine learning statistical techniques, which essentially uses statistics to come up with models, predictive modeling on data. In this case, we're talking about text data that will basically be used in what we call a corpus of text. In the case of ChatGPT and the popular tools that we use, it's often then the internet and the sources of data that comes from what we create. In some cases, the old Twitter, which is now X, Wikipedia has been used for that text corpora to make models on what could be the next words if you prompt it using text to return text that it thinks. But AI has evolved to also become predictors of images. It can create video. It can create sound. If some of you heard music that was created by AI, it gets quite interesting. But essentially, it's just a predictor system that predicts music tunes, bits and bytes. And in ChatGPT's case, it just happens to be language.
Okay, so the underlying principle is that it can essentially process very quickly what we have created. And it also, it sounded like you make it like it's a bit of a gamble in the sense that you said it predicts the next word that is most likely. Now, I didn't hear you mention anything about like fact recollection or comprehension. Can you tease out, am I missing something?
Yeah, look, sometimes people say the one thing that AI lacks is logic. There are examples where you would prompt it and you can get quite humorous results because of the lacking logic. The human brain is quite a wonderful organ in terms of the logic. What we deem to be quite obvious would not be obvious to an AI system. Why? Because it is using what it has to predict what it thinks you need. Based on your prompt, based on how it interprets your prompt. And yes, it's getting better. Yes, it is using more complex models of how it predicts, but also then what it used to predict from. But it is still not using what we call logic or reasoning to get to the answer. It's still combining a lot of data to get to a new insight or data. So it's very good at combinations of data, summarizing. But yes, it could be flawed in the sense that there's not necessarily fact checking. It's what we call hallucination or even fabrication. It creates things sometimes that does not exist by combining bits of data that did not pre-exist in that form. So it's taking snippets. A good example is if you ask it to give you a reference for an article, there might be a page number and there might be a journal that exists, but that actual reference does not exist. It was fabricated. So one must be very careful if you use it, especially for scientific purpose, and think that it's always right. And that's essentially what I teach students as well, is how to scrutinize and criticize and think twice about the answer that AI gives, because it's not necessarily accurate.
Okay, so can we move this into perhaps like a practical example? So AI is being used in the area of viticulture at the moment. So can you give an example of perhaps just one way that it is being used and how those perhaps hallucinations can crop up?
Yes, indeed. So there are many applications. Look for I think in the future for climate prediction and other complex models, it would be more useful yield prediction, for instance. But I want to use a very tangible example. There's an app called Sci. It's brought out by an agricultural organization that I've just tested and said, oh, how much fertilizer should we actually? It's a chatbot essentially that works in WhatsApp. So I tested it and saying, how much fertilizer do we need to give a vineyard with a yield of X, situated in Robertson area, with a climate that is, similar to Robertson. So I gave it quite a comprehensive quote and asked, okay, give me a tons per hectare fertilizer requirement. Of course, it first gives you the disclaimer in saying that, no, consult your consultant, because this is just an answer that we get from many data sources. But it was blindingly accurate in terms of what we thought, and I've soundboarded it with some of the other viticultural consultants from Vinpro, etc., including Etienne. And yeah, there was not a total inaccurate result. That is, the Sci app is essentially a combined database from more credible resources in terms of fertilization records and other technical sheets. So that's an example of a sub-database of AI that was created for a specific purpose. And in that way, many corporations, many companies are doing these kind of things where they're actually creating their own repository. And I think in viticulture, in winemaking even, it will be a case of creating something which you have more trust in as a corpus of text and also a model that can give you good predictors, and then have a way to scrutinize the result before you just make an recommendation for give so much tons per hectare fertilizer. But I must say, there's these type of application, which for a consultant is complex reasoning, a lot of calculations on a calculator. Those things will probably become redundant in time because of the fact that these models can actually do quite complex combination of different text sources and even mathematical calculations.
So have you encountered any areas where, or recently, where it has gone horribly wrong? I mean, you talked about it lacking logic. Have you seen that play out in your experience?
Well, where I teach students, it has played out quite interesting because, and I use that actually as example. So I have a question that I ask students. It's like an 8-mark question on what should we consider when we establish a vineyard site somewhere in, for argument's sake, Stellenbosch. And it's an 8-mark question. They could freely answer quite a few things, saying maybe terroir is important, maybe climate would be important, soil would be important, what wine style you want to make. So I just prompt AI to ask what are the considerations. And I have my memo, which I give in the exam, and I have AI's memo. And I ask students to draw conclusions from who's right now. So actually, we look for errors in AI. And yes, it recommended some things which I think students and me didn't agree with. I won't say it's gone horribly wrong. Where it does go horribly wrong is if you ask for references for those statements. And then you start, and this is where one must be very careful with AI, not to use a single tool. I teach my students on an array of about 60 tools that we use now, from getting scientific literature, getting other things like imaging or whatever created. So using only ChatGPT or Gemini or Copilot is dangerous because they are good at different things. If you want specific references, because you want to do fact checking on whatever it says is fact, then some of these tools are very good at giving you exact references with good, explanations of why these references are relevant. So yeah, where it goes horribly wrong is when you just leave it and you prompt a very short prompt and you trust it. Every time it goes horribly wrong when you do that.
Thank you. That's super helpful. So what I took away from that is that your database, you need to understand what database it's referencing. And the second thing is that even if you don't understand the processes, because some of it might be really, really complicated, you can still safe or have a fail-safe by using multiple systems. So you can, at least, if you don't understand it, at least get another AI to double check the AI that you have been engaging with. That's fantastic. So on the positive side, what are some of the really meaningful breakthroughs that you've been encountering, or at least researching and think may be possible in the next short while? You mentioned already complex calculations for fertilizer. What else are we seeing?
Yeah, look, I mean, we're all hoping that one day you could, have a tractor with a camera drive through your vineyard and you can say, oh, the yield estimation based on the counts of flowers in the vineyard is more or less this, with a 7% error. You can you can also look forward into predictive models of phenology. Phenology is when things will happen in terms of harvest time. So those complex modeling, even then pulling that through to the tank space you need to go one step further. So I think what the capability is, and to summarize the capability of AI, I don't think the human is going to disappear from the whole equation. It's going to put us on superpowers, because if you are a consultant, if you are a winemaker or viticulturist working together, also on the market trends, I think we'll get to that in the webinar, but basically linking those things together and making projections, also financial projections on what is sustainable and efficient to do, those complex reasonings, it can then piece together, basically put us, and I use the term augment us, give us superpowers, to have powers of reasoning, but still we must apply logic. Still we must apply our own, as we say in Afrikaans, jou gesonde verstand. We must apply that logic and reasoning above the model to say, does this make sense? There might be flaws, there might be issues. We also know garbage data in, garbage out. That's the biggest problem I have here, because we need to also see the ways we log data, the way we do record keeping on the basics. If we want to make a model that can be better, we need to use the right data points to actually inform the model. But I am very positive about the fact that we can be on superpowers especially as consultants and decision makers in the value chain using AI.
Okay, so if I've understood you correctly, there's already kind of farming assistance in predictions of what we might need for a healthy biome, and you're also saying we can predict yield. Is it able to detect disease in the vineyard or predict disease? What else are we seeing?
Colleagues of mine are working on even a photographic system to look at leaves, grapevine leaves, and then do essentially not AI as such, but machine learning models to look for patterns and to see if we can do disease prediction, fungal prediction, etc. My colleague here at Plant Pathology, Lizelle Mostert, has a big project with a couple of engineers involved where we're looking at that. But we cannot claim that we can do all of that already. It's quite a bit of work to put thousands of images together. Same with yield prediction, even from satellites, from drones, and then from proximal sensing, cameras close to the leaves, close to the bunches. At the moment, we still need all of that information in a model to see how close can we get, because I don't think any model is going to be 100% accurate. We must also decide what is our margin of error that we can tolerate and then work with those systems within that. But I'm very positive on disease prediction, better climate models, looking at heat waves. We have a project here looking at heat wave prediction, and then the decision making behind that. When should we irrigate? How much? How do we mitigate the heat waves? That's a project that we are also going into. And then the other applications could also be things like tank space prediction, along with yield prediction, going further than just the vineyard, looking at the actual logistics further in the chain. So, and site selection, my other colleagues from, or a student of mine that started a company called Terraclim, they're working on site selection models. So even before you plant the vineyard, to know that this is probably the best place for the Cabernet Sauvignon with this style of wine, and the predictors can say, okay, that place, that site, climate, soil, everything comes together in the best way, that site. And they're working on a so-called multi-criteria model, which is in essence also a downplayed version of AI, and it might be augmented a lot by AI to do site selection prediction, which would be very, very useful to our industry.
So if investors are listening, should they be opening their wallets in order to find images that can predict leaf roll in existing vines, or is that already in play?
It should still be. There's a lot of funding needed. There's a lot of, and that chain from research work. Remember, research work is just one part of the picture. You do need a company or somebody that will execute these models. So in the case of site selection, there's a Terraclim already that looks at that models. They are funded partially also by the industry to implement those models and to go further with it. So that it doesn't help to do only research, because there will be students that graduate. You won't yet have a model and something like a SI chat bot that's going to show you what the yield will be. So getting that chain right, and you need investment in all places, in the research domain, in the industry domain, where the industry bodies fund that, but we need companies, and I would advocate local companies, get the engineers involved, get the local companies involved, help them, get investment into them to make this possible in the future.
Well, without getting too political, that was exactly the message from the South Africa Wine Day Out, where everyone is feeling worried about the challenges that they face, and one of the big solutions, as amorphous as it was, is collaboration. So, absolutely. I mean, it sounds like you're saying the exact same message.
Yeah, thank you. Not a single company or a single researcher is going to solve this problem. Thank you for the opportunity.
No, absolutely. Thank you. So Albert might have to leave, but hopefully he can stay with us as long as possible, because I have a feeling he may have a few more comments to make in the conversation. But I want to move over to John. Now, with Albert, we've been talking a little bit about, sciencey stuff, disease protection, chemical requirements, and on it feels rather intuitive to believe that an AI robot would be great at sciencey stuff with measurements and numbers, rather than touchy-feeling things like emotions and sentiments. And yet, John, you've done a lot of work with AI, largely in the area of marketing, specifically with large language models, and marketing often has to do with touchy-feely things like emotions. Can you tell us what exactly a large language model is? We also heard Albert talk about it, and why it's useful in the area of marketing or at all.
Yeah, brilliant. Well, thanks for having me on the podcast. Very exciting to be here, and already I'm learning a lot from Dr. Struve. So I think AI has been around 70 years, but the big explosion that happened when ChatGPT arrived was really because the underlying algorithm, the transformer, has proved so much more effective than anyone expected. So really, a large language model like ChatGPT, like Gemini, is just trying to predict the next word. And the extraordinary thing is that if you have a complicated enough a set of these transformers and you add all the words that humans have ever generated, as Dr. Struve was sharing, and you give it enough training, you end up getting something that's very good at words. And when you have something that's very good at predicting the next words, it looks a lot like the way we think. It looks a lot like it's applying logic, even though it doesn't have its own logic. So even though there's nothing in it that makes it truthful, it becomes very, very good at words. And I think there are all kinds of applications in generating words, summarizing words, transforming words into other forms, finding the sentiment of words that these large language models are surprisingly good at. And it's one of those things where the more people have spent their lives in AI and machine learning, the more surprised they are that just adding compute power, that just adding training data to these basic algorithms has produced such an incredible effect. And that's why we've seen this explosion in AI interest in the last few years, because large language models and the broader areas, generative AI, it's not cool to talk about AI anymore. You talk about generative AI, which includes a picture and stable diffusion and all those elements as well. It's been so much more effective. This idea that you can predict the next token, that you can predict the next word, can be applied wider than just language, but even in the area of language, it's just incredibly powerful at creating these thinking machines, or things that look like thinking machines.
You used the term stable diffusion. Can you just unpack that?
Yeah, so you asked me about large language models. Large language models are a subset of generative AI. The image generation that you see in DALL-E or in Imagen 3 or in any of the other things, that's really using something that's analogous to the large language models, but doesn't work exactly the same. But that's how these images are being generated, which obviously I think everyone's played with it a little bit, but that's really driving forward the creation of how we even think about anything visually.
So essentially, it would be deciding, according to statistics, what is the most likely next pixel. If I asked for it to draw me a tree, it would just go pixel by pixel statistically. Is that what you're saying? Or
yeah, I think there's the way it summarizes the data and then expands it out again. But I think the similar kind of underlying mechanic with the same transformer algorithms, the same enormous amount of training data, which then means that we can prompt it to get the different outcomes there with the same challenges and some of its own challenges around just working out how it got to that or where that image came from.
So you've had to market a lot of stuff in a lot of contexts. Can you tell me a little bit about, as an outsider, someone who hasn't necessarily been directly involved in marketing wine brands, when you engage with the wine industry, which I know you do, what is your feeling? What are some of the applications that perhaps we are missing, or perhaps that you are fairly new and that you think beleaguered, unprofitable wine producers could engage with?
Yeah, I think it's a great question. I mean, I think the insight is that the way we engage with a wine that we haven't tasted is through words. Words are actually enormously important in experiencing wine. And what large language models do is they allow us to create words really well. And I think that's where the opportunity is. You have expert winemakers who aren't necessarily expert wordsmiths. And the ability to, we can, if we have some time later, we can play with one of the models a little bit. The ability to get to a 60% draft very easily is incredibly powerful. If you're wanting to write a 1,000-word article, if you're wanting to write a tweet, if you're wanting to write a wine label, the ability to quickly get to an okay draft, which you can then tweak and make sure that it's true make sure that it reflects how you're wanting to reflect. I think that gives a huge leap in productivity for people who didn't think their job would be writing and suddenly find that their job involves an enormous amount of writing. And so I think that whole category is something where immediately tomorrow, whether it's writing emails, writing wine articles, understanding and translating articles, putting them in new formats, I think there's enormous opportunity in the wine industry to just increase the productivity through the generation of better words. I think that's probably where the biggest opportunity is that I see.
So if I'm interpreting you correctly, it sounds like the kind of lowest common denominator human, perhaps someone who can string words together but not write, will be replaced by something like AI. And then it takes someone with strategy to take that piece of text saying, well, okay, I need to tweak it because these are our brand's core values, or this is the market we're trying to hit, so I'm going to tweak this and that. But you're using a base product. Is there applications in marketing that provides insight? So in the reverse, where instead of generating content, it is able to generate insights. Is that playing out like Albert was talking about with yield prediction?
Yeah, look, I think some of the yield prediction and the incredible things that are happening there on some of the fertilizer app that Dr. Streva was describing, that's not my area of expertise at all. When I'm looking at the words, large language models, when they generate words, like we've just been talking about, are very prone to hallucination, aren't great at truth. You definitely need to fact check. When they're reducing words, my experience is that they're much more accurate when they're summarizing. So I think that is a huge opportunity. They're also very good at picking up things like the sentiment of the article, right? What are the salient points? What are the, look through 1,000 reviews of my wine and tell me what most people feel, or do men and women experience this wine differently? So I think this ability to process huge amounts of language and bring out the salient points is incredibly powerful. And the interesting part is you can use it with a notebook.lm there's so many free tools that you could do, that you can literally just upload your PDF in of your words and then start to have a conversation. And I think it really is that conversational user experience that ends up being so powerful, that you can apply the knowledge you have with this ability to summarize areas out of your own data in order to have truth injected. You want to have your own corpus, as Dr. Streva was sharing. And then once you finish that conversation, you can get your large language model to summarize it, and to summarize it in whatever format you want, or to write an article, or to build a podcast based on the conversation you've just had with it. And I think that manipulation of word, that shrinking down, that transforming it, that expanding up, is really, really powerful in large language models, as long as we've all been saying, the overall truth has to reside in the user. There's got to be a human in the loop, and they've got to own the outcome of that, because I think there's always the risk at the moment with large language models that they hallucinate and they generate some of their own facts.
And I suppose perhaps one of the other things that you kind of hinted at is the ability to ask the right questions, which, I mean, there was an example of a company a while back called Brand's Eye, who, against all the political pundits who were saying the first time around that Trump wouldn't be president, they had this sort of crowdsourcing model where they get a whole lot of people to examine social media, and they actually predicted that Trump would become president when no one else did. And that was based on humans doing the analysis. And I guess if I'm reading you rightly, you're saying that machines can now do that much better. Their analysis, their as you said, summaries are much better. But you still need humans to actually ask the question, to actually say, well, hang on, let's explore sentiment in this context, or let's subdivide the query.
It's worth jumping into sentiment a little bit, because traditionally machine learning has struggled with sentiment. The way you would do it is you would have given a whole lot of examples of text, and you would have said, this is an angry one, this is a happy one, and you would have trained the model that way. The surprising thing about a large language model is somehow through the process of predicting the next word, it's somewhere in the depths of the machine worked out that it's very important to understand the sentiment in order to predict the next word. And therefore, it's incredibly powerful at telling you the sentiment of a piece of writing, even though that's not what it was specifically trained for. It's been trained for the next word. It's one of the surprising outcomes of this. So I think humans, I would say, probably are very good at it, probably better. Large language models are surprisingly good at it, but very fast and can help operate at enormous scale. And I think that's the benefit where they are. Not that they're better than humans at sentiment necessarily, but that they can now do it at enormous scale. So with someone like Brandseye, you needed an army of people. Now you would have a combination of that army with the scale ability to just look at millions and millions of words in informing your answer.
Yeah. So you talked about surprises. In fact, like you said, the reason ChatGPT exploded was because of how surprisingly good it was, right? So surprises can be delightful, like on Christmas morning, but then it's also only a matter of time in any of these AI conversations before someone brings up Skynet and Terminator, where humans develop this defense network and to protect humans or protect planet Earth, and it decides actually that planet Earth needs to be protected from humans, and they get obliterated. That was a surprise. No one saw that one coming. So unless you watched Terminator 2, then you would have seen it coming retrospectively. But so forget global annihilation. That kind of thing, that kind of negative surprise can, I'm sure, play out in either marketing or in viticulture. And I wanted to ask John and Albert, like, how are we safeguarding? So maybe, John, you can tell us first, like you said, we need humans, but are there other safeguards that we can use? And then we'll go to Albert after that.
Yeah, I really was hoping that question was for Albert. No, I think we have to think about this very carefully. So there are two main issues that one of the challenges is the truth. And when I work with executive teams, the thing I really emphasize is large language models are bad at truth. Right? They're very good at words. They're bad at truth. You need to be, you cannot use ChatGPT as your Google. This is a bad outcome. Now, ChatGPT and Gemini, they're trying hard to make it more truthy, but I still don't feel. The second challenge is there's very low interpretability. So it is basically impossible, practically impossible to say how a large language model got to any particular answer. And that actually with any complex system tends to be the case, any of these large generative AI systems. And that's a huge issue when you start to place reliance on it. When you start to, either because it automatically makes decisions or because humans say it's mostly right, so I'm not going to make the decisions myself. And I think those are the two practical challenges right there today. I think because of the challenge with interpretability, we also have no idea, as we give these things agency, the ability to ask their own questions, the ability to trigger actions, we have no idea where that will lead. And there are a lot of people who most understand these things that are pretty terrified about how clueless we are and how willing we are to just let these things free on the internet, put them in personified bodies by putting them in a robot. And so I think there's genuine concern about that, because we just do not know the second and third order effects of these things. We know what we designed them for, but the truth is we don't understand exactly how they get to an answer. Right? There's a Google researcher in one of his academic papers that says we attribute the success to divine benevolence. Right? Like it's very, very hard to understand exactly how they get an answer. And so it's going to be very hard to predict how these things will play out if we unleash them. So I think it's a huge challenge.
Yeah. So that is such an important distinction that you made. Sorry, Albert, I want to get to you, but between analysis or prediction and actual action. I think that, so we just need to hold that idea in tension, I think, for all the rest of the conversation, especially when we get to Kira just now. But Albert, can I hand over to you?
Yeah, I want to outline two concepts. The one is when we talked about technology, even before this hype of ChatGPT hit, we already knew that the fifth industrial revolution was not just coming, it was here. And what is the fifth industrial revolution other than the fourth? The fourth was the integration of technologies into like biological technologies, into physical technologies, etc., and big data. So AI was already coming, it was already there. Then came the fifth industrial revolution, which we can argue we are already in. The question is not, can we do something and can AI do something? Because it might be able to do something in 5 years. What we are reasoning about now, emotion, sentiment, those things, it might come frightfully close to that, and even a form of decision making. The problem is, should we? And that's where the ethics of technology now plays in. And with many technologies, those questions come in. There should be checks and balances. And I think that's what John has been also saying. Some people are sitting upright currently and say, how do we legislate? Like with the self-driving car, there needs to be checks and balances in the system. We cannot just leave it untapped. That's my first point. The second point is, and it comes to my role as a lecturer, as a person that imparts knowledge. Why do you trust me? You trust me because you think I have knowledge. I've acquired the skill and the ability to reason. I have a long track record in viticulture or technology or whatever, so you would trust what I say. I am teaching students that AI, and I've written an article recently with a colleague on trust and AI. Why do we blindly trust? And there's actually a psychology behind that. And what I try to teach my students is not to even blindly trust me as an imparter of knowledge, because I'm also not perfect. Why should you then trust AI? So I think that's a good principle to bring in. And it also boils down to our scientific mindset, our philosophy of scrutinizing, criticizing, not just trusting blindly. And I want to make those 2 points. Yes, I think it's coming, but should we allow it? I don't think we can just leave it unchecked. Number 2 is, let's learn how to not trust in all circumstances.
But Albert, just a follow-up question to that is, and it's, I think you guys have outlined it beautifully, and I'm going to go over those processes later. But so a lot of it is caution, trust, double check, have redundancies, know your database. But it feels like it's going to become increasingly common that we don't know that we're using AI. So even, I mean, you use Google Maps. I assume there is some sort of artificial intelligence that's been in work. I mean, John said it's been around since the 70s, right? So it's already happening. We don't know that. I didn't know I was using artificial intelligence, and so I trust it. Now that's just a route. If it takes extra 5 minutes, it doesn't matter. But what happens when it becomes so seamless that we forget to check because we don't know we're using it?
So I'm going to say a very scary thing now. When last did you fly in a plane? Do you know that there's something called autopilot? Do you know that it is getting, very much in terms of modeling, in terms of decision making, a tool that the pilot uses? If the pilot should have a stroke or there should be a problem, that tool could actually take over for parts. Are you trusting it? Well, we've all been trusting it, partly because the pilot sits there in front and the door is closed and we don't know all the details. But this is very similar, and we've reasoned along those lines that yes, we are blindly trusting many technologies. It does not mean, and I think Kira can maybe also come in here, because we have a concept called ground truthing. So how many accidents have there been where maybe the autopilot misfunctioned? Do we know that? How do we ground truth? How do we test? You mentioned disease prediction. Can we actually test the model and see how much times is it wrong to start trust it more? But you're totally right. I think we are, as humans, we tend to, if a machine acts like a human, we tend to trust it. If we can't see it, we tend to trust it. Is it right? Is it good? That's another question. But you're going to fly in a plane, and I'm afraid you'll have to trust the autopilot at some stage.
Well, my daughter was laughing at me the other day because she heard me thank GPT for its answer. And she said, "Why did you thank it?" And I thought about it for a while. I was like, well, just in case they do take over the world, maybe they'll spare me because I was polite, at least. But Kira, sorry, I've made you wait a long time. And actually, I think it's a perfect time to bring you in, though, because as we said, we've been talking about prediction, we talk about words, sentiments, ideas, but you are working with all of those, but you're taking it a step further and building systems that actually has real world sort of ramifications. Now, I know that some of your work is confidential, but perhaps you can share the outlines of the sort of models that you're working with and what you're hoping to achieve with winemaking or assisted winemaking processes in the cellar.
Yeah, so I've been on this journey for quite some time already. I actually started out this whole thing. I was originally a process engineer and then got into the winemaking perfectly by chance, and the two actually meshed together really, really well. So I initially started looking at simply automated sampling systems and then using models for predictive capabilities. So what we were seeing a lot of is that samples needed to be extremely clarified in order to be able to see exactly the chemical makeup of a sample, whereas we were moving into needing methods to analyze them straight from the tank. So I built quite a lot of these models to take into account like the yeast, the turbidity, if there was still a bit of gray particulates floating around. That's where this all started out essentially. And then I started moving into more long-term and almost forecasting methods, but using quite a bit of maths. Now, what's so wonderful about maths is you can use it to describe virtually anything. If you want to look at how things move, different projectile arcs, or how things accelerate, there is always going to be some sort of mathematical equation that can describe how things move and how things change. And if you look at a wine fermentation, what you're effectively doing is just trying to describe overall changes. So the models I've been working on for the past 4 years is if we were to get in a batch of grapes from a winery or whatever, we would first analyze them, find out all of the composition, the sugars, the titratable acidity, all of that. And then if we plug this into a bunch of equations that can describe the change, obviously knowing how fermentation carries on, how yeast ferments and everything, we would be able to then predict exactly how the anthocyanins, the tannins and everything would be extracted, what the final alcohol would be. And you would then be able to sit with a batch of grapes and potentially have a forecast of exactly where it might land up at the end of the day based on the grapes. So you could then start making decisions around stylistic choices. You could see exactly how you want to tweak the process before you even really get it started. That's the kind of things that I've been working on. Now, what I'm hoping to achieve with something like this, if you already know where a process is going, and potentially if you can already see where it might go wrong, you can already start implementing corrective measures or those tweaks a little bit before they even happen. You can also start preparing in advance so that you can start using your resources available to you a little bit more efficiently, because obviously every company, every winery wants to try and use things as efficiently as possible to save money, save time, also for environmental factors. You don't want to use water where you can possibly save it, those sorts of things. And another really, really beneficial thing of these types of models, which I don't think a lot of people consider, is that they can also be used for training purposes, because it basically acts like a simulation where you can train people on exactly what to look for, what they should keep an eye out for, but you then don't need to almost have like a sacrificial batch of grapes to do that. You don't need to wait 10 days and use a tank and space and all of that to be able to do that. So you would then also be able to give the people the quick, effective training that they would need without having to then pump time and resources into that as well. So that's another aspect of these type of models, which I think could be extremely beneficial for wineries. And yeah, that's basically what I've been working on for the past couple of years.
So if I'm hearing you correctly, the first thing you're saying is that samples can be read in their raw state, so a lot quicker, or there's less work that has to be done to get fairly accurate readings. And
much less work,
which then obviously saves a whole lot. It saves. So I mean, that's one of, I think, the things we kind of have all assumed we haven't mentioned outright is time saving. We're all talking about resources, and so that is a huge thing, and that's kind of what John touched on earlier as well. Like if you're not using it at a base level to save time, then you're missing a trick. But beyond that, there's a whole lot of other ways you can use it. The second thing you mentioned was training. So essentially what you're building is kind of like a flight simulator for winemakers.
Pretty much. And I am an airline brat, so this whole talk of everything does also kind of built into that. So yeah, it's basically like a flight sim for wineries. And what's nice about this is you can also, there's no limit to the complexity of the model. Obviously, the more complex you make the model, the more time, the more energy you need to put into it. You need to make sure it's correct. You need to make sure it's accurate. There's a lot of safeguarding, again, you need to put into that, because the more complex something becomes, the more chances of it breaking is also a possibility.
Yeah.
But you can also potentially build into it different faults that you want to simulate, different things that can go wrong. So for training purposes, that is also something you can incorporate as well.
So if I'm understanding this correctly, and we talked about databases being important.
Yes.
And we also, I mean, mathematical modeling, is that kind of the human version where you're actually trying to make sure the model reflects reality? You
Yes.
keep tweaking the model until you're comfortable that it reflects reality sufficiently.
Yes.
So in some, is that like human machine learning?
So that would be more like a statistical machine learning, where you would have your equations, you would have a data set, a representative data set of what is going on, and then through some sort of statistical machine learning process, there are different ones that you can use. You can then train this model to more accurately represent what is going on in an actual real life scenario.
Okay, so can I just, maybe we can just zoom out a little bit, because to get a good database, especially in winemaking, for example, you need really good sensors, right? Because you want to be able to detect chemical changes, temperature changes, all in real time. Now, if you can get the sensors that are good enough, I mean, then you really can start to take those conclusions that we talked about and transform them into actions. Now, we chatted earlier in the week about the e-tongue, which,
yes.
I mean, that's able to predict certain infections or microbial infections up to 1 entire month before a very experienced winemaker might go, I smell Brett or whatever. So can you tell us, are these sensors available? What should winemakers be aware of that perhaps they're not using? And how does that change what you're building? Or how does it broaden the application of what you're building?
So specifically with your question, are you talking about specific applications like the e-tongue, or just machine learning applications sort of across the board? Because there's quite a few at the moment. Yeah.
So what I'm more saying is, what are the things that can already act? Because I think what we keep coming back to is the importance of the database. And so automated winemaking is never going to exist unless we know for a fact that we've got really good sensors that can feed good data in. And so I'm saying, are there things like the e-tongue out there? Are there other devices that perhaps winemakers should know about that they're not using? I mean, I've never heard of a winemaker in South Africa, and I talk to them a lot, using an e-tongue, but they are available. They are available. They seem like amazing. So my question is, why is no one using them? And maybe the answer is because of something that I'm not aware of. So that's what I'm asking you, I think.
Okay, fair enough. So from what I've come across recently is that the e-tongue and things like that seem to be very much more cutting edge, because they're trying to replicate human senses, which are extremely, extremely complex. What is, however, very, very commonplace is things like infrared, where they're looking very much more at just the chemical composition. A lot of people are trying to link those to certain sensory properties. And at the moment, they're also trying to build models that can predict the sensory qualities and stuff from the chemical composition, which is also very, very interesting. But to my knowledge at the moment, the e-tongue and things like that are about where we're at the moment. I think why a lot of people are not using them is, at the moment, it is very expensive to implement something like that. Also, if you're going to implement a system like this in your specific winery, even though it may already have quite a reliable database, it may not be a database that is specific to your application. You would then need to tailor it very much to what you need and your needs. So that would then be quite a long, protracted, expensive process to now get your own data in a form that's usable to basically tailor it to your needs and stuff like that. So I think that's where there's still a little bit of a gap between what is coming out in the scientific field and why a couple of these places aren't really implementing these things yet.
Yes.
And a lot of these times, you might be able to get an instrument like this into your cellar or into your winery or whatever, but having an option available to drop off a sample at an analytical facility where it still is a lot cheaper, I think a lot of people are still going to rely on analytical methods that they maybe trust a bit more than, pumping quite a lot of resources into a new instrument that they'll need to bring in and set up, stuff like that. Yeah, I think that's where the bit of a gap is getting in the way.
Yeah. Albert, did you want to add to that, or were you?
No, I think, look, Akira's right, but the fact is these are research instruments, a lot of them. We've just collaborated, or we want to collaborate with a UK company that's even able to reconstitute wine based on the GC-TOF, GC aroma signal or signatures. And that's very proprietary technology, very niche. It's going to be imported technology, so very expensive. And as Kira mentioned, is it then fit for purpose? So, and yeah, there are a lot of technologies, even on the viticulture side, which we've seen, big promises, big hype about what it would achieve, but then you put it in context in South Africa, in the wine industry, and it's not necessarily, all it's hyped up to be. So I think she hinted at that it's many of these are still research tools. Yes, there are publications and things out there, but the reason it's not implemented where I see a lot of technologies is cost, local servicing of that technologies, because you basically need researchers to still service and calibrate and work on that. Not everybody has the capacity to appoint those people. So yeah, and then of course the last point of that is it then accurate? Even with all that things in place, what is accurate to you? What if you get a sensory profile, then what do you compare it to? So you still need a whole sensory panel to say, again, to ground truth what you are seeing from the sensor or machine.
Yeah. So I think we then can add to our little list. Albert, you said earlier, trust is key. And Kira, you said cost. I mean, that's another thing, right?
Yeah.
You have to be able to make sure that you're recovering your investment. But there's I think another one that we can add to it that we haven't discussed at all today, because there's a fascinating paper written by Douglas Bryson and Glyn Atwell about the application of artificial intelligence they're from the University of Burgundy. And one of the major obstacles to Burgundian winemakers, and perhaps they are a unique genre of winemaker, but Burgundian winemakers are very skeptical of AI because it just, wine is not about computers, it's about the soul and magic. And so, I mean, you're a mathematician that's been working with winemakers. Do you think that's a thing that perhaps some of it is just like, well, wine is not about algorithms, it's about alchemy and the human spirit?
I've come across some very nuanced views throughout my time working with this. What I found is that most of the people I've interacted with, their primary concern is whether or not something like this would be applicable for smaller scale people and wineries where the ethos is more centered towards the minimal intervention side of things, which I completely understand. That's a whole different way of thinking about it, and it's on its own. It's a really, really wonderful way of looking at it. But I also think at the end of the day, it might be a little bit of a misconception, because the way these models are built, it's not really trying to take any control away from the people who are making the wine. It's just really a way of getting to those decisions a little bit quicker. As you said, with the e-tongue, it can detect like the infections a month sooner than a winemaker. But ultimately, the winemaker would then still be making the same decision based on that detection of the infection. So the people who I think have a bit of a deeper understanding of exactly how these tools are used understand that it is simply a tool that is even more so an extension of human creativity. And there's a bit of a misunderstanding that a lot of people who are very, very anti this may think that it's completely trying to take all of that away from the human element of the winemaking process.
I almost feel like minimal intervention winemakers should be into it more than anyone else, because if you can detect something 1 month earlier, any adjustment you have to make is going to be way smaller.
Oh, yeah, of course.
It kind of makes me think visually of the sport of curling, where you throw that kettle down the ice and then sweep furiously. It's like you're never touching the actual kettle itself, you know? So, and I think things like these predictive algorithms enable us to keep our distance because we don't have to make drastic course corrections. So yeah. And I think that's a really good explanation. I hope there are winemakers out there who understand that you still get to hold the magic wand.
Absolutely.
But it can just make your life a little bit easier. So
Can
we're
I
kind of,
make a comment here?
yes, yeah, please do.
So I just tongue in cheek, I was laughing while you're saying all of this because I visited the chateau in France. You know, outside it was the most beautiful place, and I won't name it for reasons, but when I went inside, it was banners of we use electric tractors and we are, you know, testing drones and testing hydrogen balloons to check if the frost is coming to our vineyards. So on the surface, you know, it's like these Porsches that you now will see in Norway that's electric. They don't have the sound of a Porsche. They're very refined under the bonnet, but it's still a Porsche, you know. So the actual, and that's a good example of under the bonnet, you know, it's good to have technology as a backup, as a methodology of checking yourself and of doing the ethos. But I do agree. I often tell my students, would you like to make wine in a lab? Because a Californian company, a startup, has done it. It's not great tasting wine, but where do you get the spirit and the ethos and actually going to the winery? And I like to use that analogy to make my students think about what are they really doing. It's not just the process. It's not just making the wine chemically. There's a much more to it. And I think that will always stay. That will not just disappear. There's an ethos. There's a whole nuance and an environment. Luckily, and that's what makes South African wine, I think, so special.
I think what's also important to remember with systems like this is, and this is at the moment, it might evolve later on, but the suggestions it might make would be things like temperature corrections or punch down regimens. It's not going to, at the moment, make extreme stylistic suggestions to a winemaker. So it still isn't going to take that human and that almost magic alchemy element out of it. It's just going to make these small little corrections to maybe keep things on track, help with the extraction a little bit, help make sure the fermentation doesn't get stuck. It's not taking the spirit out of it and making that. And at the end of the day, it is just a suggestion. It's not an algorithm connected to a series of pumps and valves and everything that's going to automatically kick in and completely remove you from the equation. So
yes,
that can happen if that's what somebody would want, but they aren't taking that choice away from the people who still want it. And I think that's also very important. And that's also, as everybody was mentioning earlier with the safeguards and everything, that's something that's very important to keep in mind if they are moving towards systems like this, is to enable that choice with systems
can I pose a question to Albert and to Kira from Dr. Marinda Kruger, who's now in California? She says many wineries have the FTIR instrument, infrared inference, which have so many applications through machine learning and modeling. I'm amazed why this is not being used more by spectral data. Albert, I'm going to pretend I understood that last bit, and then.
Yeah, I've heard. And again, it's about the decision-making capability of those models and what it suggests to do, or what it is actually, if you go along the cycle of data intelligence, it's first data and then, you know, information, and then it's knowledge, and then it's wisdom. You know, to get to the wisdom of an spectral instrument, you do need to know and Kira, you can come in here because you also have knowledge on this, but to know the spectral regions that's of interest, to have a system that actually can reliably predict certain chemical or then sensory or volatile aspects, whatever you are sensing with the spectra. So it does not yet make a decision. So it's again one of those very useful tools to screen faster, to get even high throughput analysis. Online sensing is now the thing, that you have a pipe going from one tank to the other, and you can actually use spectral technology even on dirty, material or juice or must to do quick screening of what you are doing. So it's that, and that's the advancement of sensors really, is to have real-time data, to have quicker, not to send a sample to a lab. And I like the comment because it also alludes to having the instrument in the cellar. But I think the next advancement is actually having online sensing on tanks and on barrels, etc.
Fantastic. Thank you. Let me see if there are any more. And then do you guys, I found this fascinating. I just want to check in whether any of you have some questions that you would like to ask each other about the various areas that you're working on. Nothing. Okay, well, so if that's the case, I mean, that's great. I'm going to, yeah, sorry, John, did you have something?
I mean, I think it's fascinating, this conversation we have as someone who's not as intimately involved in the wine industry as Albert and Kira. For me, this whole question of how it affects the value of the wine, whether we use technology behind it, it gets at the heart of what we're making as wine. It's always been a story of the romance and the juice, which is why things like wine of origin really matters. What is the narrative and what is the product? So I think with all the application of this technology, I think winemakers should be thinking about, how can I use this technology to both enhance the quality of my product, which is what we've been talking a lot about, but also the romance, the narrative. I need to at least make sure it doesn't undermine it, because clearly wine made in a lab doesn't have the romance of wine from Burgundy. At the same time, there are ways in which you can enhance the narrative. We've spoken about the ability to tell the story better, all right, which can enhance the narrative. So I think if we're always thinking about the romance and the juice and how we can use technology to enhance both of those, then I think we're in a good space at applying technology without undermining the very thing, the very joy we're giving to customers.
Well, I'd just like to ask you that question, John. So, I mean, just an example, because I mean, essentially what you're talking about is copywriting in some senses. So, I mean, how would you, if you were absolutely clueless on how to do that, how would you use a large language model to help you even begin to think about I mean, that's a challenge, right? How do I sell lab-made wine to someone who finds romance in wine important? Can you solve that problem with AI?
Yeah, just give me a minute. No, look, I think that's a great question, but it comes at the heart of what you're wanting to make as a winemaker, right? So I think it comes if you're a winemaker that the words don't come easy to, and you can put into Gemini or ChatGPT everything you think about the wine, what it tastes, what it is, and you can start asking it to say, how would I phrase it to a customer who values this? How would I explain the story to that? I think you'll get all kinds of interesting ideas. I mean, one of the learnings about generative AI and large language models is that they're not great at repetitive calculations. That's what computers were good at up to a few years ago. That's what we've always thought. What they're great at is something creative, like a creative attempt. And I think that's what's really interesting here is for that exact problem. I make my wine in a lab. I want to sell it to people who have romance. That feels like an impossible problem. But I can guarantee you 20 minutes of testing out with large language models will get you some creative solutions, some of which will be terrible, but it turns out that it's free when it's terrible. And if it's valuable, you can use it. And so I think that's pretty interesting when you talk about, and I think copywriting almost diminishes it. For me, the telling of the story it's the juice and the narrative. It's a product and the romance. So I think telling of the story really does enhance people's enjoyment. If you can tell the story well behind the wine, people actually experience it as better wine. And so I think we mustn't dismiss it as, the copywriting. No, this is how the winemaker can tell the story of the wine in the way that's most relevant to the people that are going to enjoy it.
Yes, and perhaps some of the biggest advances in my experience in marketing have been the ability to iterate. as you said, it's not very good at repeat calculations. And it used to be, if you gave a prompt for an image or a paragraph, you'd go, that was great, but can you change it a little bit? And then it would say, I'm sorry, I can't remember what we were talking about. Let's start again. Well, that's what it seemed to say. But whereas now you can say, tweak it a little bit, keep these facts, drop that. Can you help me with this? So that iterative process is in itself an advance. Okay, so we are at 11:05, which, I mean, I could stay longer, but I know that you guys all have important lives. So I'm going to try and summarize it, what you guys have said. And what I'd really like for you to do, everyone just stares at me blankly when I finish my summary. Like, I guarantee you I'm going to miss something out. So please, if I miss something out, just say, hey, don't forget this was a really important point. So that's to you, panelists. So what we started out was talking about the difference between artificial intelligence and human intelligence. And I think one of the major things that popped out from what Albert was saying was that garbage in, garbage out. Your database is really, really important. And you need to remember that it is not telling you the truth. John said it's bad at truth. What it's doing is it's really taking a gamble on what the next most likely letter is, or in the case of an image, the next most likely pixel. So it is making a guess, a prediction based on statistics. And those statistics are based on what you feed in. So there's actually, if you need to envision it, you need to have the little decision-making like statistic thing, and below that is a big fat database. You cannot have an AI without a database. So whenever you're using any of it, you need to understand where is it getting its information. And that's hugely important when it comes to safe or double checking fail safes, is to use more than one tool. Albert talked about you can't just use ChatGPT and then go, it's true. You need to cross-check that, especially when it's starting to make predictions that you don't fully understand. So John talked about how it's actually been around for 70 years. AI has been around a very long time, and it's getting better and better. And it's not just for numbers. It's not just for words or pictures. It can actually put that all together and start to assess sentiments. It can make analyses on data. It can tell you this should be the next action. And this is where a crucial point I want to make is that when engaging with AI, when you shift from those analyses to action, that is still an ultimate point of human responsibility. And it's one that we really should take quite seriously. So we talked with Kira a little bit about some of the work she was doing with mathematical modeling and how this stuff is saving loads and loads of time. So if you're not using AI already to save you time, either in the vineyards or in the cellar, then you are missing a trick. And you need to sit down and ask yourself, am I or aren't I? Because as we started out with that quote, AI won't replace humans, but humans with AI will replace those who don't have it. The next thing we talked about was sensors and how important it is, again, to have good data coming in. But again, it doesn't take the decision-making process away from human beings. And that is something that, for now, will sit in our hands. And the things we need to consider when applying AI are, do we trust it? And we can answer this by asking those questions about database and redundancies and fail-safes. And the second thing is it cost effective? Because, I mean, we've all probably spent money in a flash on some AI program that actually doesn't save you any time because you spend so long fixing its little glitches. So assess it properly before you invest. And when you do invest, make sure that you are cross-checking things. And I love something that Albert said right at the end, which was, you need to check the wisdom of the machine or of the database. I thought that was a really lovely way of putting it. Like, yes, it's a robot. Yes, it's just data. And yes, it's just making probabilities. But when we can't see it, we engage with it as a human. I'm not the only one that thanks ChatGPT, just to make sure I'm being polite. And when we do that, we are, in a sense, assigning trust to it. And when we assign trust to something, we need to ask, what is its wisdom? What is its source of knowledge? So I think that is it for today. Have I missed anything, John or Kira? I know Albert had to go.
Look, I think that's a great summary. I would steal the chance for a last word. I think it's so uncertain to see where this thing would develop, the second order, the third order effects of this. I think I really encourage executive teams to create a culture of safe play, work out how you can safely experiment, how you can start using the tools, how you can make the mistakes while it's still easy. And I think, making sure your people understand what these large language models are, what the available AI tools are, so that you can start experimenting. I think then you can get to be the people who discover how they're most useful, rather than other people discovering them and you being left behind. So for me, it's all about safe play.
Absolutely. That's yes, Kira?
I'm very happy with the summary as well. I think it really captured the points absolutely perfectly.
Well, in fact, the last thing I did forget was what you said, which was training. And I think what John has just pointed out is kind of they're connected, that we need to be able to experiment and fail, because that is how you future-proof actually your business. And secondly, a lot of the stuff can be used to train in advance, especially in the cellar. So for people who have winemaking apprentices or assistants and want them to grow and develop faster, this is a great avenue through which to at least try it. So I want to thank you both for your time, and Albert in his absence, thank you so much for being willing to share your expertise and your experience. You've given us an hour and 10 minutes here, but for you guys, it's years and years and years of engaging with what is quite a complex topic. So thank you so much. For those of you at home, I appreciate you sticking with us. Please know that this webinar will go onto the website. It's also available on YouTube, and we also have a whole series of podcasts which are on the Vinimark website. So all of those will be available, and you can also submit any questions, perhaps following up this on LinkedIn or on X, and we'll try and answer as many of those questions as well. So this is not your only opportunity. I hope you have a productive rest of your day and a good rest of your week. Thanks again. Bye-bye.
Thank you very much for having us.
Thank you. Bye-bye.